All right, so here we are in section 8.3. Okay, so what I want to start off by saying to you is just reminding you, if I talk about the circumference of a circle, the circumference of a circle is pi d. So if I solve this for pi, I get circumference over diameter. So what that's saying, what I'm trying to say to you is that pi is just a ratio. Pi is always the ratio of a circle's circumference to its diameter. So just like we have that ratio in circles, we have ratios in triangles too. So these ratios, we call them trigonometric ratios. Sometimes you'll just hear it referred to as trig ratios, okay? Trig ratios are equivalent ratios for similar right triangles. So these are only going to apply to our right triangles. So basically what you have here, here's your right triangle. So this is our hypotenuse side. So the trig ratios that we have are sine, cosine, and tangent. There's other ones, but those are the ones that we're going to be worried about. If you notice in the calculator abbreviates them with the first three letters. So you've got the sine, cosine, tangent there. All right, the sine of angle A. So whatever angle I'm referring to, the sine ratio is always the opposite over the hypotenuse. So if I was talking about angle A, the opposite side would be A, and the hypotenuse is C. So I'd have A over C. Again, just like pi is the ratio of the circumference to the diameter, in the triangle, the sine ratio is the ratio of the opposite side from the angle over the hypotenuse. Cosine of angle A is the adjacent side over the hypotenuse. So if I'm talking about A, B is adjacent over the hypotenuse. And then your tangent ratio is your opposite over your adjacent. So again, if I'm talking about angle A, opposite over the adjacent. Your parents, or if you say to somebody, hey, I'm taking geometry, they might be like, oh, SOHCAHTOA. So SOHCAHTOA stands for S, sine, opposite hypotenuse, okay? C, cosine, A, adjacent hypotenuse. TOA, T, tangent, opposite hypotenuse. So if you hear that SOHCAHTOA, then you can just remember that they're talking about sine, cosine, tangent ratios. Again, just ratios aside. All right, when a problem says to you, write the trig ratios, you are just writing the ratios. You are not solving anything, you're just writing the ratios. So it says for angle T. So the sine of angle T, so I'm just going to use the three letters like it does in the calculator. So here's T, sine is opposite over the hypotenuse, so I'd have 8 over 17. The cosine of angle T. Cosine is adjacent over the hypotenuse, so I'd have 15 over 17. The tangent of angle T, so T is the opposite over the adjacent, so I'd have 8 over 15. And then I can do the same thing for angle G. I'm not using the right angle ever. It's always the other angles. It wouldn't make sense to do the right angle because like the opposite would be the hypotenuse, so then you'd have hypotenuse over hypotenuse. So that's why it's always these other angles. So the sine, again, is opposite over hypotenuse. So if you notice here, the opposite angles, the sine of one is the cosine of the other one. So then the cosine of angle G, so it's going to be the sine ratio, so the cosine is the adjacent over the hypotenuse, which is the same as the sine is the original one. And then the tangent of angle G, it's just going to be flipped because it's opposite over the adjacent. Okay. All right, so those are the ratios. So what this means, though, is that we can use these ratios to help us find missing pieces. So sometimes the missing piece is just a side. So then I can use these ratios as they are right now. So if I'm trying to find a side, so in this one right here, if you notice, here's my right angle. I have this angle right here. Here's the hypotenuse, 54. W is opposite the 54. So I have an opposite and I have a hypotenuse. Opposite and hypotenuse is my sine function. So the sine of 54 is equal to W over 17. So then, if I cross multiply here, W is just going to be 17 times the sine of 54. All right, this is very important, what I'm about to tell you. On your calculator, it says mode. If you see here, there's radian and degree. We want to make sure we are in degree. So I go down here, go over, press enter. So you want to make sure that you are in degree mode. Radian mode is going to give you a different answer. You're not going to use radian mode in this class. We're only going to use degree mode. So you want to make sure, again, what I did to do that. So I went to mode, and I went down, and then over to degree, press enter, okay? So then second quit or second mode, you should be back out there. All right, so now I can do 17 times the sine of 54. Actually, let me show you something. So the sine of 54. So I type the sine of 54 in, and I get that answer right there. So the sine of 54 degrees is always that number. So there's some ratio. I don't think this will work. No, there's some ratio that gives me that decimal there, and that is the sine of 54. So if I have a 54-degree angle, these sides have to be in that ratio. So to find W, I can just do 17 times the sine of 54. Okay, so W, I'm just going to round it to the nearest tenth. So W is approximately 13.8. Okay, and this one right here, here's my 28. There's the right angle, so this is the hypotenuse. I don't have the hypotenuse of this one. This is opposite the 28. This is adjacent to the 28. So if I have an opposite and adjacent scenario, I'm going to use the tangent function. So the tangent of 28 is the opposite over the adjacent. Okay, if you notice, this one's different from the first one. The W is in the denominator. I'm going to do a little trick here. I'm going to multiply both sides by W. Then I'm going to divide by the tangent of 28. All right, so you can, if you're really good at your algebra, then you don't really need to take that extra step, but I wanted to show you what I'm doing here. So in this one, when the W is in the numerator, you're just multiplying those two things to get your answer. And the W is in the denominator, you're going to take, this is 0.1, sorry, you're going to take this number, and then you have to divide it by the tangent. No different, though, here in my calculator, so I'm just going to go 0.1, or 1.0, sorry, divided by the tangent of 28. Okay, so here W is approximately 1.9. Over here, there's my right angle. This is the hypotenuse. I have the 33-degree angle, so this is the adjacent. Could you find the third angle? Sure, and then you sine, sure, but I'm just going to show you how to use the cosine. So if I have adjacent and hypotenuse, that's my cosine functions, the c. So the cosine of 33 degrees is equal to the adjacent over the hypotenuse. So this is another one where I just have 4.5 times the cosine of 33. So this one is, W is approximately 3.8, okay? Okay, all right. So we can use the sine, tangent, cosine, so sine, cosine, tangent functions to find sides. What if I want to go backwards and find angles? So if I want to go backwards and find the angles, if you look on the calculator, above the sine, there's like sine to the -1, cosine to the -1, tangent to the -1. Those are my inverse functions. So those, when it says they're using inverses, so all of these ones allow me to find angle measures. Okay, so down here, find angle P and angle Y. All right, here's your right angle here. So this is the hypotenuse. So P, if I'm talking about P right here, this would be adjacent to P. This would be opposite. So adjacent and opposite and adjacent are tangent. So the tangent of angle P is equal to the 41 over 100. To get rid of that angle P there, I'm going to say the measure of angle P is equal to the tan inverse of 41 over 100. You don't have to really write out that first line right there, but I just wanted to remind you that's what it is. So like I'm getting rid of that tangent by putting the tan inverse, and I'm going to put an m in front of it. So then on my calculator, again, you want to stay in that degree mode. I'm going to go to tan inverse. So I did second tan there, 41 divided by 100. And I get that answer right there, and again, I'll just round it to the 10th. Okay, when you do this, you could just find the measure of angle y by doing 180 minus the 90 minus the 22.3, so then you get 67.3. If you wanted to use, so if I wanted to use a trig function, here's y. This would be opposite, and this would be the adjacent. So it would be still the tangent, so I'd have tangent of angle y is equal to the opposite over the adjacent. Then I would say the measure of angle y is equal to the tan inverse of the opposite over the adjacent. Remember, they're flipped for y because it's a different side of the triangle. So I would go in here, and my measure of angle y would be 67.7, which is what I was anyways. And then I could also find p from this one as well. Okay? All right, I've got a couple homework problems here that we'll do together. All right, so 16. So in 16, I am finding a side. This is my hypotenuse. This is opposite that one, and this is adjacent. So I have the opposite and the adjacent, so I'm using the tangent function. So the tangent of 64 degrees is equal to, so 64, x is opposite, 70 is adjacent, so opposite over the adjacent. Again, I would type this in the calculator. So x is going to be equal to 7 times the tangent of 64. These ones say round to the nearest tenth. So in my calculator, I'm going to have 7 times the tangent of 64. So I get 14.4 approximately. Okay? All right, 17. 17, same type of problem. I've got the hypotenuse there, and I've got the opposite of 36. So if I have opposite and hypotenuse, that's my sine function. So the sine of an angle, so in this case 36 degrees, is equal to the opposite over the hypotenuse. Okay, this is in the denominator, so what ends up happening is I end up with 10 over the sine of 36. I plug that into my calculator, 10 divided by the sine of 36, and I get 17, it's a 17.0 approximately, okay, when I round it to the 10th. Okay, so that's that one. All right, 26. All right, 26 is one in which I'm finding an angle measure, so I have to use an inverse function. So 26, opposite, hypotenuse. So if I have opposite and hypotenuse, those are my sine functions. So the sine of x is equal to the opposite. So in this case, in 26, the opposite of x is 17. The hypotenuse is 41. So 17 over 41. I will be using the inverse function. So x, I'm just going to use x there, is going to be the sine inverse of 17 over 41. Oops. No. So 17 divided by 41. So for that one, and I think it's what I said, round to the nearest degree. So when you round, remember you only look at if I wanted to round to the nearest degree, you just look at the first place after that. So I would only look at the 4, so that would round that to just 24. I don't look at that 9 there. So x is approximately 24 degrees. Okay? And then the last one I have here is 30. Okay, so 30 says an identity is an equation that's true for all the allowed values of the variable. Use what you know about trigonometric ratios to show that each equation is an identity. So 30 is saying that the tangent of x is equal to the sine of x over the cosine of x. So let's just think here. The tangent of x is the opposite over the adjacent, right? The sine of x is opposite over hypotenuse. Cosine of x is adjacent over hypotenuse. If you have a fraction divided by a fraction, you remember you flip that fraction. So those h's are going to cancel. So, yep, that is an identity. This does work up here because they both equal the opposite over hypotenuse when I simplify it. Okay? All right, that is it for this section.